either this is wrong or this is a huge discovery. And we think that it's a huge discovery.
Have you ever wondered what lies beyond our familiar celestial neighborhood? In a groundbreaking discovery, this revolutionary space observatory has identified a staggering 500 unknown objects that boldly made their way into our solar system. These enigmatic entities have sparked a flurry of excitement and curiosity among astronomers and space enthusiasts alike, as they challenge our understanding of the cosmos and hint at the infinite mysteries that lie beyond. Brace yourselves, because the James Webb Telescope has just unveiled a mind-boggling revelation that will leave you in awe. When we think about space, particularly our solar system, we often assume that everything that will ever exist is already there. It's hard to imagine something new suddenly appearing. However, that is not the case. Celestial objects are indeed created in space, but it doesn't happen very often, and most of the time, these new objects are not even found in our solar system. Everything we know about the things we can see, including ourselves, everything on Earth, and all the galaxies in the universe, only makes up about 5% of the whole universe. That's why it's surprising that the James Webb Telescope, an amazing space exploration tool, has discovered 500 large objects near us. This discovery could change what we know about our solar system. The James Webb Space Telescope, JWST, is a new and advanced type of telescope for studying space. It's even better than the Hubble Space Telescope. The JWST can focus on a type of light called infrared, which helps us see things that emit longer wavelengths. The JWST was launched on December 25, 2021, and it's the biggest and most powerful space telescope ever built by NASA. It has special instruments and technologies that can revolutionize our understanding of space. One important thing about the JWST is that it can see things with very high detail and sensitivity. It can observe objects that are too old, far away, or faint for the Hubble Space Telescope. By capturing weak signals from celestial objects, the JWST can explore the early stages of the universe, study how galaxies form, examine the atmospheres of planets outside our solar system, and help us understand dark matter and dark energy, which are still mysteries to us. Now let's talk about the telescope itself. The JWST, James Webb Space Telescope, has an amazing primary mirror. It is made up of 18 hexagonal segments that are made of beryllium and coated with a thin layer of gold. This mirror, which is 6.5 meters in diameter, is really good at gathering light. It helps the JWST capture detailed and precise observations of things in space, like stars and galaxies. But it's not just the mirror that's important. The position of the JWST is crucial too. It is located at a special spot called the Sun-Earth L2 point, which is about 1.5 million kilometers away from Earth. Being at this spot helps the telescope avoid problems caused by the Earth's atmosphere, like turbulence. This means that the observations made by the JWST are clearer and more accurate. You might think that this telescope is only for looking at things really far away, but that's not true. The reason the JWST is placed at the L2 point is so that it can explore whatever it wants to. Our solar system is a delicate balance of different objects, and the JWST helps us study their movements. If anything changes or moves out of place, the telescope can detect it right away. But the JWST doesn't stop there. It also looks at the outer planets of our solar system, like Jupiter, Saturn, Uranus, and Neptune. But with the advanced capabilities of the JWST, we can now learn about their atmospheres, weather patterns, and cloud formations. This gives us a better understanding of these distant planets and their importance in our solar system. James Webb Space Telescope is an incredible tool that also explores mysterious things like dark matter and dark energy. Dark matter is a substance that is much more abundant than what we can see, and it affects how galaxies move and how the universe is structured. Dark energy is a force that makes the universe expand faster and faster. The JWST helps us study dark matter by observing how it bends light, which helps us understand where it is and how it is distributed. The telescope also looks at nearby galaxies to learn about their structure, how stars are born and changed, and how they interact with gas clouds. By studying these neighboring galaxies, we can also discover new things about our own Milky Way galaxy. The JWST also keeps an eye on big celestial events like exploding stars and bursts of powerful gamma rays. By analyzing the light emitted during these events, scientists can learn about the stars themselves, how the explosions happen, and how the elements produced in the explosions spread out in space. However, the JWST's attention is not solely focused on supernovae and gamma-ray bursts. It also pays close attention to a wide range of powerful events happening throughout the universe. These events include tidal disruption events, where stars are ripped apart by supermassive black holes, as well as collisions between neutron stars, which produce gravitational waves and emissions across different parts of the electromagnetic spectrum. These events provide glimpses into extreme cosmic environments. The JWST's quick response capabilities allow it to promptly observe and capture the afterglow of high-energy gamma-ray bursts. By studying these bursts, scientists gain a deeper understanding of the physics behind these extraordinary events and the environments in which they occur. In the 1990s, scientists found the first planets outside of our solar system with the help of the James Webb Space Telescope. Since then, we have discovered more than 3,000 distant worlds that orbit other stars. However, only a small number of these planets have been directly seen or photographed. Most of them are too far away for us to see directly, so we detect them by noticing a decrease in the brightness of their host star when the planet passes in front of it. But the James Webb Space Telescope has the potential to change that. In September, it took its first picture of a planet directly, without relying on the dip in starlight. This is a significant moment, not just for the telescope itself, but also for the field of astronomy as a whole. Sasha Hinckley, an astronomer at the University of Exeter in the UK, who led this observation, expressed the importance of this achievement in a statement. Saturn's moon Titan is a very strange and interesting place. It has rocks made of frozen water, and there are rivers, lakes, and seas made of liquid methane and ethane. Unlike other moons, Titan has a thick atmosphere that is blurry and has clouds of methane. James Webb Space Telescope collected data on these clouds. The scientists studying Titan with the telescope were thrilled when they received the data. They discovered that the telescope captured not just one, but two clouds. One of the clouds was above the moon's largest sea, called Kraken-Mare. Additionally, the JWST has discovered hundreds of unidentified objects in our solar system. While some of these objects may be familiar, such as asteroids and comets, others could be entirely new and unknown. The diversity and abundance of these objects offer a unique opportunity for scientific exploration and discovery. By studying their properties, paths, and compositions, we can learn valuable information about the processes that have shaped our cosmic neighborhood over billions of years. Analyzing the characteristics and behavior of these objects helps scientists refine existing models and theories about the formation and evolution of our solar system. Furthermore, these findings have implications for understanding the formation and evolution of other solar systems in the universe, contributing to our understanding of the cosmos on a larger scale. The JWST's detections also provide potential clues about the nature of dark matter, a mysterious substance that makes up a significant portion of the universe's mass. By observing the gravitational interactions and effects of these massive objects, scientists gather crucial information that may help unravel the mystery of dark matter. Similarly, these detections offer insights into the nature and influence of dark energy, which is the mysterious force driving the accelerating expansion of space. Exploring the origins of objects ejected from black holes could provide valuable evidence of their immense power and influence. Black holes are known for their ability to pull in everything around them, but their intense gravitational forces can also tear apart stars and planetary bodies, creating a chaotic environment where debris and fragments are violently expelled. However, the question remains, could black holes also eject material from within? And there you have it, the James Webb Telescope has once again astounded us with its incredible capabilities. With the recent discovery of 500 unknown objects entering our solar system, our understanding of the universe continues to expand. What could these mysterious visitors be? Are they remnants of distant galaxies or perhaps evidence of extraterrestrial life? Share your thoughts in the comments. Stay tuned as we eagerly await more groundbreaking discoveries and prepare to embark on new cosmic adventures.